All right, we're going to finish up the notes from the very first section here. So, starting off from where we left off, we're going to start off with some vocabulary terms. And we talked about kind of this term in the last video, collinear points, except we talked about non-collinear points. So this is just going to be the exact opposite of what we talked about in the last video. So collinear points are just points on the same line. Okay, the co meant together, like to cooperate. Some other co-words. What are some other co-words? Can't really think of any off the top of my head. But co means kind of a togetherness. So same line points, points on the same line. Coplanar points, if you kind of use that same reasoning, would be points on the same plane. And coplanar lines are lines on the same plane. Okay? Primarily out of these three terms, we will focus on collinear points, non-collinear points. Coplanar points and lines, we don't really discuss a whole lot, but they might pop up every once in a while. So example 6 here, name 3 collinear points. We need 3 points that are on the same line. And if you look here, we kind of have 2 planes going on. You know, kind of picture this plane right here being like a wall, and this plane here being like a ceiling, or not a ceiling, the floor, for instance. Okay, so you've got one plane that's kind of vertical here, one that's kind of horizontal, and they do come together and collide. So we need 3 points that make up a line. Well, I could use these 3 points. So we could say points. We can't just say ZAC, but we have to say points CAZ. Those are 3 collinear points. We could also give the example of LJ, and K. These 3 points are on the same line. They're on line N, if you will. And really any 3 out of these 4, out of L, J, K, and D, would be an acceptable answer. So more than one possible answer here. You pick which one stands out to you the most. All right, part B. Clear this off here. Name 3 coplanar points. So we need 3 points that are in the same plane. Well, we've got 2 planes going on here, so 3 points, and they don't have to line up to make a line, but they just need to be in the same plane. So for example, I could give points, again, CA and Z. CA and Z are all in this plane, and that's it. I could also give the example of points, E, B, and G. E, B, and G are all specifically in this plane. Now, an example that would not work. Points L, J, K. These 3 points here. And the reason why I couldn't use those 3 points is because technically these 3 points are in this plane, and they're also technically in that plane. So they're not in the same plane, they're in multiple planes. So this would be an example that would not work. And part C, name 2 coplanar lines, 2 lines that are in the same plane. Well, here I've got some options. We could use line CZ, which would be that guy, and I need another line that's in this same plane. Well, I could use this line. It's in this plane. It's also in the other plane, but these 2 together technically are in this plane. So I could say line CZ and line LJ would be one way of naming it. You know, I could have named it line N if I really wanted to. Okay, but I'm just going to pick the 2 points there instead. So those 2 lines are in the same plane. They're in plane P. Alternatively, I could have said line LJ and line H. So again, this line and that line are technically both in the same plane. Now they're both in plane M. Now, how many planes are in this ice cube? Kind of think of how many sides are there, if you will, to this ice cube. Okay, and there would be, you know, this is kind of like a cube, literally a cube, but there are 6 known planes that we can visually see here. Technically, there's infinitely many planes, but there are 6 main ones we can see, right? There's the front plane, there's the back side, the left side, the right side, the top, and the bottom. Those are the main 6. Technically, there are infinite, And we will talk about some other examples of besides those 6. But how would you name the top plane? So if we were wanting to talk about the top plane, how many points do we have in this plane? Well, we've got 4 known points in the plane, and those are the 4 corners, if you will. H, or really E, F, G, and H. Now, how many points do we need to name the plane? Well, we really only need 3. It's 3 or more, but here's an example of where you may just want to go ahead and use all 4. Doesn't matter which order you name these in. Not particularly, but the nice thing about naming points, or one of the, not really said rule, but a nice rule, is you pick a point, and then you go either clockwise or counterclockwise as you're naming. So notice I went counterclockwise. I went E, F, G, H. I could have also named it plane, I'm just going to use the ditto marks there, E, H, G, F, and go clockwise instead of counterclockwise. It's not very proper, and I'll put this in red to indicate that it's not very proper, to do, let's say, E, G, F, H. That would be like me going from E to G, I'm cutting through the plane, then F, and then back to H and cutting through it. You don't really want to kind of zigzag and cut through the plane. You kind of just want to mainly stay on the outside of it. So those are ways I would name the top plane. But technically, let me write this not in red anymore, you could name it plane EFG, just 3 letters, and that's fine. EFG would technically only belong to that top plane. There's no other plane you could confuse points E, F, and G with because they're all in the top plane and no other plane do they exist. The right plane, which would be this side over here, again, we have 4 points to pick from. We could really pick any 3 we wanted to, but again, I would go ahead and recommend just using 4. And again, just pick 1 point. I'm going to pick B, and then I would want to go clockwise or counterclockwise. It's up to you. I'll go clockwise this time and say B, F, G, C. And that would be one example out of many that would be a correct answer for naming that plane. So example 7, where do planes EHDA and HGCD intersect or meet? So EHDA, there's EHDA. So we're really talking about the left plane there, and HGCD. HGCD, that's kind of the back side back here, right? Where do those 2 planes come together? And here's a very common response that I get. Well, those 2 planes come together at H and D. It's true that they do come together at H and D, but notice, what about everything in between H and D? Technically, different color here, technically, they meet at that point, and that point, and that point, and that point. And what do we call something that has infinitely many points that are collinear? We have now a line. It's not really there, but it really is there. So we could say HD, or we could flip it around and say DH, doesn't really matter. Those are the only 2 known points that we know on that line. So that's really the only thing we could name it. Okay. Now, one thing I want you to notice is, what do those 2 planes have in common? Because again, we can use this. Both of them had D's and H's together. So even if we didn't have that picture, we would know what the answer is without it. Let's try the same thing here. Okay, again, let's pretend we don't see that picture. So what do these 2 planes have in common? Well, they both have E's and F's. So where do they meet? Line EF, or you just have to give me one here, but both of these would work. FE. So again, what are we talking about here really? HGFE, we're really talking about the top, and we're talking about the top and EFBA. Where's EFBA? EFBA, the front. So where do the top and the front come together? Well, the top and the front come together right here with what connects E and F, which is line EF. Technically, it should keep coming out this way to the left and to the right. It's not really there, but it's implied that it's there. Oh, whoa, whoa, too far, too far. Okay, now this one, ADCB and FGHE. There's nothing in common here. Does that necessarily mean that they don't meet? Well, it just depends. So here's a case where we really do need a picture. So ADCB, all right, we're talking about the bottom, and FGHE, we're talking about the top. Where do the top and the bottom come together? They don't. So where do they intersect or meet? Quick and easy answer is, again, they don't. They are, just like lines, we can have planes that are parallel. They don't touch and they don't intersect. So let's again try one blindfolded, no picture. And again, you're just looking for the things that are in common. What do these two planes have in common? They both have an FR in common. So we know the quick and easy answer is they meet at line FR or RF, and we're done. Again, the backwards style here. I'm going to give you where the two planes come together. You got to name me the two planes. So we'll do the first one together. I'll leave the second one for you to do. So QU is where they meet. Here is QU. So what two planes come together at QU? Well, really, the left side has QU in it, and the front side has QU in it. So now I just have to name the front plane and the left plane. So we can say planes, and let me go with the left side. So I'm going to use QUXT. There's one way of naming it. And again, there are many other ways of naming that plane, QUXT. So planes QUXT, and then I need to name the front. I'll go QUVR. And just put those common letters, the Q and U, as the front ones. They don't have to be there, but it's a nice, easy way to do that. Again, I'm going to have you guys do number 2 on your own. So line TS, tell me what two planes come together at line TS. And we're going to end with two postulates. The third postulate in the book says that if two planes intersect, then their intersection is, and this is what we just have been doing. So when these two planes come together, it shows here that they kind of meet at S and T, but technically they also meet at everything in between. So they intersect at a line. And the last one. Through any blank non-collinear points, there is exactly one plane. Now notice here I have an example. It's kind of like, imagine 3 pieces of paper all coming together and meeting at the same intersection, if you will. And when planes come together, we said they intersect at a line. So I've thrown in now just an extra plane, a third plane, that also intersects at that line. And notice these 3 points that are on that line, right here in the middle. I've got 3 collinear points, okay? How many other pieces of paper could I throw in the mix here that still touch all 3 of these points? And the answer would be infinitely many more pieces of paper. I could get another piece of paper that kind of fits in between this green and this yellow, slices through it this way, and comes out this other side, but it would still go through, if I can hit all 3 of those points there, it would go through all 3 points. Now the answer, if you haven't figured it out already, that it takes 3 non-collinear points to make exactly one plane. And here's the example I give. Let's take 3 non-collinear points. So there's 3 points right there. Now imagine your computer screen, your laptop screen, your phone screen, whatever you're doing to watch this video. Imagine the screen of whatever you're watching with technically is the plane that these 3 points exist on, right? Is there any other screen or any other piece of paper that you could pick up right now that could touch those 3 points but not lay exactly on top of your laptop computer or telephone screen? And the answer would be no. There's only one unique plane that these 3 points create, and that is your screen that you're watching this video on. There's no other plane that could touch all 3 of those. There could be a piece of paper that touches 2 of those points, right? But not all 3 of them at the same time. So 3 non-collinear points create exactly one unique plane. Just like it took 2 points to create a line, it takes 3 non-collinear points to make one plane. That is all for the second half of this first section for pre-AP geometry. Again, if you have any questions, please ask me during class the next day, and we will try to clear up any confusion you might have. So that is all, and adios and goodbye.